Today we will be finding confidence intervals for proportion. Recall from last unit that the sampling distributions are approximately normal for, I don't know what's behind the thinking bubble, but the standard deviation for proportions, that's what it is, proportions, is the square root of p times 1 minus p over n, or the square root of n times, or p times q all over n. If we don't know the population proportion, remember that's what the p means, then we can't find our true standard deviation, but we can use our sample statistic p hat to estimate the standard deviation of our sampling distribution. Whenever we estimate standard deviation for a sampling distribution, we call this standard error. By the 68, 95, 99.7 rule, we know that about 68% of all samples will have one p hat within one standard error of p. 95% of all samples will have p hats within two standard errors of p. About 99.7% of all samples will have p hats within three standard errors of p. Okay? Thinking bubble. A confidence interval is a set of plausible values for a parameter based on what we have observed in a sample. So essentially what you're doing is you're taking a sample and you're using that sample as an estimate of the population. If we look at the 95% level, if we reach our two standard errors in either direction of p hat, we can be 95% confident that this interval contains the true proportion. And this is known as the 95% confidence interval. I want you to take a minute and go to the link on this YouTube video. It's just a visual, in the flesh example of a confidence interval analogy. Remember, the confidence interval does not capture the mean or the proportion. Don't say the proportion falls between or the mean falls between. Okay, so reaching out two standard errors in either side of p hat makes us 95% confident we'll trap that two proportion of p. So in our figure in our notes today, we're saying this between these two ranges, which is two standard errors from above the mean and below the mean, somewhere in that range is going to be the true population proportion. Now we're going to look at a few examples. So we have a Pew Research study regarding cell phones asking questions about cell phone experience. One growing concern is unsolicited advertising in the form of text messages. Pew asked cell phone owners, and 17% reported that they had. Pew estimates a 95% confidence interval to be 0.17 plus minus 0.04, or between 13% and 21%. Are the following statements about people who have cell phones correct? Okay, so just like we did earlier in the last unit, I would underline key information. So we have 17% reported they had, 95% confidence interval between 13% and 21%. If we look at number one, we have in Pew's sample, somewhere between 13% and 21% of respondents reported that they received unsolicited advertising text messages. So our answer for number one would be no, because we know in the sample 17% said yes already, so we don't need a margin of error. Number two, we are 95% confident that between 13% and 21% of all U.S. cell phone users have received unsolicited text messages, unsolicited advertising text messages. So our answer for number two is yes, this is a confidence interval. Number three, we are 95% confident that 17% of U.S. cell phone owners have received unsolicited advertising text messages. So our answer for number three, no, we can only say we are 95% confident that the population percent falls in some interval, not a specific value. And the interval would be the extent on either side of the population parameter. Number four, We know that between 13% and 21% of all U.S. cell phone owners have received unsolicited advertising text messages. In number 4, no, we don't know for sure if this is true. We're only 95% confident. And last but not least, number 5, 95% of all U.S. cell phone owners have received unsolicited text messages.
Regarding lunch?
No, our 95% is our confidence level, not the proportion of people receiving unsolicited text. So hopefully these statements kind of help you understand what it is we're trying. Each confidence interval uses a sample statistic to estimate the population. But since samples vary, statistics we use, and thus the confidence intervals we construct vary as well. Okay, so think of the pre-sample as like the probability and the post-sample as the confidence interval. And if you look at this picture that is here, notice this green line, that represents the population proportion. And they almost kind of look like box plots, but these little guys, right, with the dots, the red dot represents the proportion in that sample, the proportion mean in that sample, and the blue line with the 2 whisker ends represents the end of the confidence intervals. So if we look at the green line, it goes through the vast majority of all those almost like mini box plots in proportion. Ooh. For the margin of error, in general, confidence intervals have the form estimate plus or minus the margin of error. And you can find this expression in the formula packet on page 2. Okay, so we can claim with 95% confidence that the population interval p hat plus minus 2 standard errors of p hat contains the true population proportion. The more confident we want to be, the larger our margin of error needs to be, making the interval wider. Okay, so if we reach out 3 standard errors on either side of p hat, makes us 99.7% confident we will trap the true proportion p. Now, if we're 99.7% confident, notice that range we have in this picture is much larger. Think about that. So to be more confident, we wind up being less precise because we have a greater range of values. We need more values in our confidence interval to be more certain. Because of this, every confidence interval is a balance between certainty and precision. The most commonly chosen confidence intervals are 90%, 95%, and 99%, but any percentage can really be used. In our next example, on January 30 through 31st, 2007, Fox News Opinion Dynamics polled 900 registered voters nationwide. When asked, quote, "Do you believe global warming exists?" 82% said yes. Fox reported their margin of error to be plus or minus 3%. Pollsters use 95% confidence levels unless otherwise stated. What does Fox News mean by claiming a margin of error of plus or minus 3% in this context? Well, if this polling were done repeatedly, 95% of all random samples would yield estimates that come within 3% of the true proportion of all registered voters who believe that global warming exists. In our next example, Sleep Awareness Week begins in the spring with the release of the National Sleep Foundation's annual poll for U.S. sleep habits and ends with the beginning of daylight savings time, when most people lose an hour of sleep. In the Foundation's random sample of 1,029 U.S. adults, 48% reported that they often or always got enough sleep during the last 7 nights. Calculate and interpret a 95% confidence interval for the proportion of all Americans who would report they often or always got enough sleep during the last 7 nights. So if I'm asked to construct a confidence interval, I'm going to want to do our 4 steps: state, plan, do, conclude. So obviously our confidence interval, and this is also in your formula sheet that you can use on the test, you're going to take your sample statistic plus or minus your critical value, times the standard deviation of that test statistic. Remember, the critical value is based on a normal model for proportions, and we use a z star in the formula. Hence, we have p hat plus minus z star standard error p hat. So our first step when approaching this problem is our state step. This is the step in which you state the parameter you want to estimate and the confidence interval. So our state is that we want to estimate P equals the true proportion of Americans who report they often or always get enough sleep during the last 7 nights with 95% confidence. For the AP exam, you really only need this P equals the true proportion of Americans who report they often or always get enough sleep during the last 7 nights. Our next step is the plan step. This is where we identify the inference method and check our conditions. So, our plan, our name of our interval is a 1 proportion z interval. For the random check, remember you have to look up in the story and make sure it's a simple random sample of sample. So it says in the story, in the foundation's random sample of 1,029 U.S. adults, so that is good, right? We already know these were randomly selected. 1,029 is less than 10% of all U.S. adults. And then for success fail, we have to take the proportion that they give us for the sample, which is 48%, and multiply it by the 1029 to be about 494. And n times q, which would be the 1029 times 0.52, is about 535, and both of those are greater than or equal to 10. Our third step is the do step, and this is where we, if the conditions are met, we perform the calculations. So our mean is obviously the 0.48, matches our context. For the 1.96, you can either look at your intro to confidence intervals for a single proportion handout, or you can do inverse norm 0.975, okay? The reason why is if we were to draw a bell curve and I want a 95% confidence interval, then that means this is my middle 95%. So my z star is located here at inverse norm 0.975, right? Because this would be 2.5% and this would be 2.5%. And when you do, you get 1.96 times the standard error, the square root of 0.48 times 0.52 divided by 1,029. From here, it becomes a calculator step, and you should get an end result of about 45% to 51%. Our final step is to do the conclude step. This is where you interpret your interval in the context of the problem. So our conclude, we are 95% confident that the true proportion of U.S. adults who report they often or always get enough sleep during the last 7 nights is between 0.449 to 0.511. Last example. Woohoo! Lacey wants to estimate what proportion of her school seniors plan to attend prom. She interviews an SRS of 50 of the 750 seniors in her school and finds that 36 plan to go to prom. We're going to calculate and interpret a 90% confidence interval for the proportion of all seniors at Lacey School who plan to go to prom. So our first step is the state step, and we're just going to say P is the true proportion of all seniors at Lacey School who plan to go to prom. That's what the question is asking. Next, we're going to do our plan step. Okay, so in our So in our plan step, we're going to call this a 1 proportion z interval today. It is random because if we look up at the context, notice we have an SRS of 50 of 750 seniors. 50 divided by 750 is less than 10%. And for success fail, we know the successes are 36 plan to go to prom. Therefore, the failures are 14, which both of those values are at least 10, so we can use a normal model. Now we're ready for our do step. So for our do step, remember we're going to start off with what happened with the sample. If 36 of our 50 in the sample plan to go to prom, that's our p-hat, plus or minus. This time, for our critical value, we want a 90% confidence interval. That's what it says up in the story, right? 90% confidence interval. So therefore, we have to think of the middle 90%. So we're going to use the inverse norm 0.95 to be 1.645. Remember, you can also reference your confidence interval handout. Times the standard error. Well, if our successes is 36 over 50, then our failures is 14 over 50 divided by 50, and then we square root. You should get an end result of 0.616 to 0.824. All that's left is our conclude. So our conclusion, we are 90% confident that the true proportion of seniors at Lacey School who plan to go to the prom is between 0.616 and 0.824. And remember, all we did was restate the question. So if the question said the proportion of all seniors at Lacey School who plan to go to prom, I have to insert that into my statement. Here's your math humor. And now you can do practice. Hooray. The end.